Hello everyone. In a previous lecture, we have discussed about laboratory test on cement and storage of cement. In this lecture, we are going to discuss about types of cement. Types of cement. There are various types of cement, but now we are going to discuss about only the most commonly used types of cement. First, ordinary Portland cement. Second, rapid hardening cement. Third, Lloyd cement. Fourth, Pozzolana Portland cement. Fifth, sulfate resisting cement. Sixth, blast furnace slag cement. And seventh, white or colored cement. First type of cement is ordinary Portland cement. This is most widely used cement for all types of construction work. This type of cement is also called a normal cement since setting is normal when mixed with water, as well as its initial setting time is more than 30 minutes and final setting time less than 10 hours. It is general purpose cement suitable for use in general concrete construction work which requires no special consideration. Then the properties of ordinary Portland cement are fineness less than 10%, soundness less than 10 mm, initial setting time more than 30 minutes, final setting time less than 600 minutes, compressive strength after 3 days 115 kg per square centimeter, compressive strength after 7 days 175 kg per square centimeter. Then applications of OPC. All construction work which are free from sulfate attack. Sulfate attack of concrete is a complex process which includes physical salt attack due to salt crystallization and chemical sulfate attack by sulfates from soil, groundwater or seawater. Sulfate attack can lead to expansion, cracking, strength loss and disintegration of the concrete. Sulfate attack is generally attributed to the reaction of sulfate ions with calcium hydroxide and calcium aluminate hydrate to form gypsum and ettringite. Then, second type of cement is rapid hardening cement. The main difference between OPC and this cement is strength develops rapidly. As compared to OPC, RSC have more rate of heat of hydration, so its strength gaining rate is more. In this cement, percentage of C3S is more and grinding is finer. As cement is more fine, it attains greater strength at early stage. C3S is responsible for first 7 days strength, and in this cement percentage of C3S is more, as well as RSC is a very fine cement. RSC have fineness about 5%. It means 5% particles are coarse particles and 95% particles are fine. It has a more surface area, so heat of hydration process is very fast. Therefore, strength gaining rate is also fast. 3 days strength of RSC is equal to 7 days strength of OPC. Due to more heat and early strength developed, the formwork can be removed much earlier and can be used many more times. Also, speed of construction can be increased and curing period is short. So, speed of construction is increases as well as economy is achieved. This cement is used for cold weather concreting, construction of road pavements and manufacturing of concrete products like fencing, posts, electric poles, hollow blocks, slabs and precast pipes. In cold weather concreting, because of surrounding temperature, heat of hydration rate slows down, so in such weather condition RAC is used. In case of road pavement, RAC attains strength at early stage, so road is opened for traffic very early. In precast concrete products casted in factory, RAC have very short curing period and attain strength at early stage as compared to OPC, so speed of production of such precast concrete members increases. The properties of rapid hardening cement are fineness is less than 5%, soundness is less than 10 mm, initial setting time more than 30 minutes, final setting time less than 600 minutes, Compressive strength after 1 day 160 kg per square centimeter. Compressive strength after 3 days 275 kg per square centimeter. Applications of rapid hardening cement. When formwork is required to removed early for reuse in other works. RSC attains strength at early stage, so formwork is removed early and immediately we can use shuttering material or formwork for other work. Road or runway repair works. During repair work of road or runway, the traffic is stopped on that road. But we can't stop traffic for a longer time. So we have to done repairing work as early as possible. That's why in such a case, RS used to minimize the traffic inconvenience in prefabricated concrete construction. Concreting in cold weather. Because of low temperature, heat of hydration rate slows down, so setting time is prolonged. And to increase the rate of heat of hydration in a low temperature and to attain strength as early as possible, RHC is used. Repair of canal banks during the rainy season. It should not be used in mass concrete construction such as concrete dams, bridge abutments, retaining walls, etc. because they liable to serious cracking due to much liberation of heat during hydration of this type of cement.
Rapid hardening Portland cement. Rapid hardening cement is manufactured similar to ordinary Portland cement but contains high tricalcium silicate, that is C3S content, and finer grinding is done for this cement. This type of cement attains strength faster than the ordinary Portland cement. That is, this type of cement attains the 3 days strength of ordinary cement in 1 day. However, this type of cement is subjected to large shrinkage and water requirement for workability is high. The cost of rapid hardening cement is 10% higher than the ordinary cement. The concrete made with RHC are frost and freeze resistant as the concrete matures more quickly. Properties of rapid hardening cement are: initial setting time of cement is minimum 30 minutes. Final setting time of cement is maximum 10 hours. The compressive strength of this cement in 1 day is 16 Newton per millimeters square and 3 day is 27.5 Newton per millimeters square. This type of cement is used for repair of roads and bridges and when loads are applied in a short period of time. As it is resistant to frost action, they are used for cold weather concreting. This type of cement is not suitable for mass concrete, as it emits more heat.
Third type of cement is load cement. This type of Portland cement is called as a load cement because it develops less heat of hydration. It develops less amount of heat of hydration during setting and hardening of cement. Because of liberation of heat during heat of hydration process is low, so this cement is known as load cement. It contains low percentage of tricalcium silicate which hydrates quickly and higher percentage of dicalcium silicate and tetracalcium aluminoferrate which hydrates slowly. The compound which are responsible for early strength of cement is used in less amount and those are responsible for slow heat of hydration of cement is used in a more quantity. It has a low rate of heat generation and great resistance to cracking and sulfate attack. The heat is developed in less amount so setting time is prolonged, therefore cracking is minimized. The rate of gaining strength is lower than OPC, therefore it requires curing for long period. The properties of load cement are fineness less than 5%, soundness less than 10 mm, initial setting time more than 30 minutes, Final setting time less than 600 minutes. Compressive strength after 1 day 100 kg per square centimeter. Compressive strength after 3 days 116 kg per square centimeter. Then application. This cement is used only in large mass concrete work such as dams, bridge abutments, retaining walls, etc. In mass concrete work, volume of concrete is more. Therefore, developed heat during heat of hydration causes increase in temperature of concrete mass, and concrete mass liable to serious cracking due to such liberation of heat during hydration of this type of cement. So, to avoid such serious cracking, low heat cement is used in mass concrete work.
Low heat Portland cement. We all know that hydration of cement generally produces a large quantity of heat due to a release of large amount of heat which results in the formation of large cracks on the concrete surface. Thus, in place of mass concreting, low heat Portland cement is preferred. The manufacture of low heat cement is same as the manufacture of ordinary Portland cement. But, the compounds evolving the maximum heat of hydration such as C3S and C3A are reduced, whereas the C2S compound is increased. This reduction of the compounds retards the chemical action of hardening, thereby reducing the evolution of heat. This action makes the cement to gain the strength at a slower rate. However, the ultimate strength is same as that of ordinary Portland cement. Properties of typical low-heat Portland cement. The heat of hydration should not be more than 272 Joule per gram at end of 7 days and 314 Joule per gram at the end of 28 days. The fineness in terms of the specific surface should not be less than 320 meters square per kilogram. The cement should not have expansion more than 10 mm for Le Chatelier test and 0.8% for autoclave test. The initial setting time of the cement is 1 hour. The final setting time of this cement is 10 hours. The compressive strength of this cement after 3 days is 10 Newton per millimeter square, after 7 days is 16 Newton per millimeter square, and after 28 days is 35 Newton per millimeter square. Uses of typical low-heat Portland cement. It is most suitable for large mass concrete works such as dams, large raft foundations, etc.
Then, fourth type of cement is Pozzolana Portland cement. Pozzolana means volcanic ash. Pozzolana is essentially a siliceous material containing clay up to 80%. In the manufacture of this type of cement, about 30% of pozzolanic material is added to OPC clinkers and the mix is then thoroughly ground. During manufacturing process, 30% of pozzolanic material is added to clinker and after mixing they ground to a fine powder. Pozzolana is a finely ground siliceous material which does not possess cementitious properties, but in the presence of water it forms a compound possessing cementitious properties. Pozzolanic material does not possess binding property, but when it comes in contact with water, CSA gel forms and possess cementing property. The properties of this cement are same as those of OPC, except that it provides to the concrete high resistance to chemical adhesives and attack by seawater. It also improves water tightness and fire resistance qualities of the concrete, and it is cheaper than OPC. Then the properties of Pozzolana Portland cement are: fineness is less than 5%, soundness less than 10 mm, Initial setting time more than 30 minutes. Final setting time less than 600 minutes. Compressive strength after 7 days 175 kg per square centimeter. Then applications: mass concrete construction like dams, bridge abutments, retaining walls, etc. Marine structure, sewer and sewage disposal work, all hydraulic construction.
Portland Porzellan cement. Portland Porzellan is manufactured by grinding Portland cement clinker and Porzellan or by uniformly blending Portland cement and fine Porzellan and mixing them together. Porzellan is an essentially siliceous material which includes a natural volcanic material having pozzolanic properties such as diatomaceous earth, calcined clay and fly ash. This siliceous material possesses less or no cementitious properties in finely divided form. Whereas in the presence of water, it reacts with calcium hydroxide at ambient temperature to form compounds possessing cementitious properties. Properties of typical Portland Porzellan cement. The fineness in terms of the specific surface should not be less than 300 meters square per kilogram. The cement should not have expansion more than 10 mm for Le Chatelier test and 0.8% for autoclave test. The initial setting time of the cement is 30 minutes. The final setting time of this cement is 10 hours. The compressive strength of this cement after 3 days is 16 Newton per millimeter square, after 7 days is 22 Newton per millimeter square, and after 28 days is 33 Newton per millimeter square. The average drying shrinkage when tested should not be more than 0.15%. Uses of typical Portland Porzellan cement. This type of concrete evolves less amount heat. Thus, it is used in the places of mass concrete such as dams, foundations etc., and in places of high temperature. It is also suitable for concreting in marine areas.
Then, fifth type of cement is sulfate-resisting cement. This type of cement is also known as super sulfate cement. It is a product of finely ground mixture of granulated blast furnace like calcium sulfate and small quantity of ordinary Portland cement. Blast furnace slag have sulfur absorption capacity. Thus, this cement consists of very high percentage of tricalcium silicate and dicalcium silicate, and a very low percentage of tricalcium aluminate and tetracalcium aluminoferrite. This combination of low C3, that is particularly liable to attack by sulfates, and C4F makes the mixture much resistant to the attack of sulfate. Then, properties of sulfur resisting cement are: fineness less than 5%, soundness less than 5 mm, initial setting time more than 20 minutes, final setting time less than 600 minutes, compressive strength after 1 day 150 kg per square centimeter, compressive strength after 3 days 220 kg per square centimeter. Then applications: marine structure, structure in coastal area, structure in creek area, construction of foundation in soil where subsoil water contains very high proportions of sulfate.
Sulfate-resisting cement. Generally, ordinary Portland cement is susceptible to the attack of sulfates, due to the action of chemicals, groundwater or seawater. In these types of places, sulfate-resisting cement is commonly preferred. This type of cement contains low C3A and comparatively low C4AF content and high silicate content. This C3A is generally limited to 5%. Sulfate-resisting cement is manufactured by grinding and intimately mixing together calcareous and other silica, alumina and iron oxide-bearing materials. The resultant clinker is grounded to produce the cement. Characteristics of typical sulfate-resisting cement. The fineness in terms of the specific surface should not be less than 225 meters square per kilogram. The cement should not have expansion more than 10 mm for Le Chatelier test and 0.8% for autoclave test. The initial setting time of the cement is 30 minutes. The final setting time of this cement is 10 hours. The compressive strength of this cement after 3 days is 10 Newton per millimeter square, after 7 days is 16 Newton per millimeter square and after 28 days is 33 Newton per millimeter square. Uses of sulfate-resisting cement. This type of cement is preferred for concrete in marine condition. They are used in foundation and basement concreting where groundwater level is high and contains sulfate. This type of cement is used in the manufacture of underground pipes which are to be used in place which is rich in high sulfate content, and are also used in the construction of sewage water treatment works.
Then, sixth type of cement is blast furnace slag cement. The blast furnace slag, which is a waste product obtained during manufacture of iron, contains all the basic elements of cement, that is silica, alumina, lime, iron, etc. It is crushed or preliminary to granulated form, which is then intimately mixed with cement clinkers, and both are then ground together to form cement. It is cheaper than OPC, except its early strength, which is less than OPC, but strength up to 28 days remains same. It has a low heat of hydration and better resistance to sulfate attack and alkalis. Because blast furnace slag have sulfur absorption capacity, so it has a better resistance to sulfur attack. Then properties of blast furnace slag cement are fineness less than 10%, soundness less than 10 mm, initial setting time more than 30 minutes, final setting time less than 600 minutes, compressive strength after 1 day 160 kg per square centimeter, compressive strength after 3 days 220 kg per square centimeter. Then applications: mass concrete work such as dam, seawater construction, foundation and abutment of bridges, pipe carrying water containing chemicals or sewage.
Portland slag cement. Portland slag cement is obtained by mixing Portland cement clinker, granulated blast furnace slag with gypsum in a suitable proportion and grinding it to a finer particle. It can be also manufactured by a uniform blending of Portland cement and finely ground granulated slag and later mixing it thoroughly. Generally, Portland cement clinker is the homogeneous mixture of materials which principally contains lime CaO and silica SiO3 with a smaller proportion of alumina Al2O3 and iron oxide Fe2O3. Granulated slag is a non-metallic product consisting essentially of glass-containing silicates and aluminosilicates of lime and other bases. This slag is obtained by processing of molten slag by rapidly chilling or quenching it with water or steam and air. This type of cement is generally developed to utilize the waste product obtained from blast furnaces. The chemical composition of cement is same as the 33 grade ordinary Portland cement, but should satisfy the following requirements. Properties of typical Portland slag cement. The fineness in terms of the specific surface should not be less than 225 m3 per kilogram. The cement should not have expansion more than 10 mm for Le Chatelier test and 0.8% for autoclave test. The initial setting time of the cement is 30 minutes. The final setting time of this cement is 10 hours. The compressive strength of this cement after 3 days is 16 Newton per millimeter square, after 7 days is 22 Newton per millimeter square, and after 28 days is 33 Newton per millimeter square. Uses of typical Portland slag cement. This type of cement can be used for all types of concreting where OPC is used. Portland slag cement has a low heat of hydration, thus can be used for mass concreting, for example dams, foundations, etc.
7 type of cement is white or colored cement. White cement is a type of OPC which is purely white in color. It is made of china clay with chalk or lime, free from impurities, and very less amount of iron oxide and manganese oxides. Increase in amount of iron oxide produced a greyish color to cement, so that it is kept as less as possible in white cement. The strength of white cement is less than OPC and it is 4 to 3 times costlier than it. White cement is not used for concreting work, it is only used for decorative work or plastering work. White cement is costly as compared with OPC because of following reasons. First, white cement is used as a base for manufacturing of various color cement. Second, the amount of chromium, manganese, iron compounds are significantly less in white cement in comparison with grey cement. Third, production of white cement consumes more percentage of energy in comparison with OPC. Then applications. First, decorative work. Second, internal plastering work. Third, waterproofing work. And fourth, it is used as a base for manufacturing of various color content.
White Portland cement. This video explains what is white Portland cement and common uses of white Portland cement. White Portland cement is similar to ordinary Portland cement except white color. The concrete formed from white cement is perfect and uniform color throughout. This type of cement is best employed in architectural purpose. This cement consists of a very slight volume of iron oxide and manganese oxide. These oxides influence whiteness and tinge of white Portland cement. White Portland cement varies substantially from grey cement principally in terms of its color. Its setting behavior and strength improvement are approximately the same as that of grey cement. White Portland cement is also used in combination with inorganic pigments, can be used to produce brightly colored concretes and mortars. Whereas, ordinary Portland cement in addition to inorganic pigments produces dull colors. White Portland cement concrete is commonly preferred for prestige construction projects and ornamental works. This type of cement is not preferred for structural purposes, as it is not economical. Comment your